All right, this week we're going over Chapter 9 on characteristics of a network operating system, or NOS. It's based on a client-server architecture. NOS manages resource sharing, other functions, authentication, and NOS components varies by version and type. Networks use servers. Network use servers exceeding minimal requirements, meaning uh, when you set up a server, it's going to use more than what the minimal requirements are as far as memory, hard drive, space, things of that nature. So you have to determine what the server architecture should be before installing so you can buy the right components. So, what kind of apps are you running? Clients connected, storage space, how much downtime can you afford? Things of that nature. And when you're considering the server architecture, types of applications you're running from your server, like say maybe MS Office, things of that nature, uh, reliable, there's different vendors for different hardware for servers, like Dell's a popular one. So when it comes to client support, from a NOS perspective, within a network operating system, you can create new users. You can enable clients via computers, allow those computers to share resources, allow users to share resources, and facilitate communication. The client server architecture also allows for login process to give rights through Active Directory on where you're located, what apps you can access, what functionality you can perform. From Windows XP up to present day, um, gives broad support for authentication and accessing resources. So when a user connects to a server, it then replies back to that client with whether it be a file, whether it be for access to a certain folder, immediately through their rights to that server. Middleware refers to devices that connect to in between client and server. So middleware would be things like your switches, your hubs, your routers. Three-tier architecture refers to client-server environment involving middleware. So you've got your clients, you've got your middleware devices, and then you've got your server. You also have what's called users and groups in a network operating system through Active Directory, where you can add users to different group buckets and give them access to certain things from administrator down to limited user. Within network operating system, you can grant rights to access their own network files, their own network drives. If you put them in a group, it's easier because then you can manage it by group via user. So an example, some groups might be teachers can read and modify, full rights to grades, no access to staff. Students can read programs, no access to grades, no access to staff. Administrators have no access to programs, but they have full access, or read but modify access to grades and full control to staff. When it comes to the layout of the users and groups, it's in a hierarchical group. It simplifies management. You have inherited permissions. And after a group, a user group restrictions are applied. Like a client can be allowed to share network resources. In modern network operating systems, users can be added, printers can be added, servers can be added, data files, applications. The directory of a NOS lists all the resources available, from users to printers to servers. LDAP is a popular way to authenticate lightweight directory access protocol. LDAP has the following components: an object, a thing or a person, attributes, properties, and schema, set of definitions. Two types of schemas. You've got classes and attributes. Classes refer to the type in the directory, whether it's a class of a user, class of, like, say, a printer, just to give a couple examples. Attributes refers to their rights and privileges within the network. So here we have a NOS directory of a user account, their computer, printer, and domain that they're located on. So here in the schema, they're given the rights here to give, once they give the username and password and authenticated, they can access remote devices. Continuing on with LDAP, you have what's called containers or OUs, organizational units, allow you to subdivide your network. And they've always used representation of a tree format. A tree has a roots, branches, and leaves. So here we have an example. The root would be something like Rock Valley College. Containers could be also departments, like, student, faculty, maintenance, whatever. You can add to a container, just like a tree can add to a branch. Within containers, you can add other containers. And then finally, leaves. Leaves would be things like printer, a user, a file server. A leaf you cannot add to, just like a tree. Leaf is the last part of the tree. So you draw out your tree when you're setting up a network, figure out your needs, current and future, and start building it. If you see something in the future, you can use the dotted lines like this to represent it. Also, shared applications are one thing you can run specifically on a server. And with that benefit, you can buy per license, per user license, per seat license, or what's called concurrent license, meaning you have access, so many users at the same time can access a certain application. It keeps track of, after installation, it keeps track of who accesses it at what time. There is a problem with file share file access, multiple users simultaneously accessing the same data, the same program files. You could have cross-writing and cross-overwriting, things of that nature. Shared printers allows for flexibility to share printer throughout the organization. So instead of a printer directly connected to one computer, like the one above, the one on the bottom left or middle left can be printed to from any computer. Installing a printer is fairly easy today. Most modern printers, when you connect them to a network, automatically give the option to connect to a network once it sees the network name and location. Modern servers allow for maximizing memory, processor, hard drive usage. Memory within servers are generally much greater than memory in a normal computer because it's having to do more work. Multitasking on servers also, it can be do multiple simultaneously events one at the same time. And multiprocessing just refers to being able to do things multiple items sequentially, not one after the other, but all at the same time. So minimal requirements. This is a Windows 2000 Server 2012 requirement, but you'll notice the RAM is very low disk space needed. And again, these are minimal requirements, but when you install them, it's generally going to be much greater than that just for usage. These are all minimal requirements that all softwares have, even your client OSs. You can remote into servers to manage, which a lot of times happens. You can remote from anywhere in the network. Administrators can switch between different servers simultaneously within remote connections. And lastly, we're going to talk about domains. Domains in a server is a group of users, servers, and other resources shared within one domain. It's in the client-server architecture. And anytime you talk about domain, you talk about what's called Active Directory, which contains a domain database. It allows you to organize and manage all the resources like computers, users, devices like printers and servers. Here we have a university domain separated underneath it with the containers of all the departments. And within those departments, you can also have subcontainers of other subdepartments. Domains not configured by geographical boundaries. Domain controllers control all the objects within the domain, and all of the members are not stored directly in the information. So example here, you've got Active Directory replication. So if you have a group that you created and you want the same rights and privileges for another group, you can replicate that group, rename it, and then reuse it. Organizational units within a domain tree can be nested. You can have sub containers within containers. And I already talked about this earlier, about the tree format and the tree domain, how it is used again by Active Directory. You can also have a forest, which is a collection of one or more trees, like large organizations would have. So here you'll see life sciences here has its own domain, and within that, multiple divisions are connected. Within each division, a couple leaves are represented by the person's names. You can also set up trust locations between two types, two-way trust or explicit one-way trust, where you can trust between two domains. So in this example, you could have life sciences and engineering both trusting each other in one location. So that concludes Chapter 9. You can continue reading on. I'll have the PDF posted here also in the module for this week.